Boys and girls, this is Mr. Manise here again with another super cool video. In this video, I'm going to walk you through how to solve all the problems on the radical functions and rational exponents test review. My disclaimer, as always, is to go and work the test review problems on your own, and then and only then come to the video and iron out any mistakes or misunderstandings that you may have. So before we get started here, looks like there's a little something here in the paper. I'm not really sure what that is. Like a shadow or something behind the paper. Oh, I know what it is. I know, it's a Clemson tiger paw. That's what it was. So yeah, isn't that beautiful? Orange and purple tiger paw. Anyway, let's go ahead and jump right in and get started. Okay, so in number one, in these first three, we are going to be solving the radical equation, and remember to check for your extraneous solutions to take your answer, plug it back in, and make sure that the equation holds true. So let me zoom in here just a little bit. Alright, so when I'm solving these radical equations, I want to isolate at least one of the radicals by itself, and then I'm going to square both sides and solve. So something like this, I don't have the radical isolated yet. I've got to ask myself, can I divide both sides of the equation by the coefficient? Yes, I can. Negative 7 does divide into negative 70. Now, if this were some other number like 18 or something, where 7 doesn't divide into it evenly, then I'll probably just go ahead and square both sides. But since this does divide evenly, let's go ahead and divide both sides by negative 7. And I will have x minus 3, the square root of x minus 3 equals negative 70 over negative 7 is 10. And so now I have a radical isolated. Let's go ahead and square both sides. When I square the square root of something, they just cancel each other out. So on the left, I'm left with x minus 3, and 10 squared is 100. Add 3 to both sides, and x is equal to 103. But we've got to go back and check and make sure that this holds true. So if I plug in 103 minus 3 was 100. The square root of 100 is 10. 10 times negative 70, 10 times negative 7 is negative 70, so that checks out. So x equals 103 is our correct answer. Number 2. Okay, I've got one of my radicals isolated, so I'm ready to square both sides. Both of these square roots and the squares cancel, so I'm left with negative 9 minus 2x equals 2x plus 15. And now I have a simple algebraic equation to solve. Let's keep a positive variable, so I add 2x to both sides. Negative 9 equals 4x plus 15. Let's move this guy over here to the other side. 4x is equal to negative 24. Sorry, y'all can't see that. Divide by 4, and x is equal to negative 6. Okay, let's take that and plug that back in. Alright, so a little bit tricky here. So when I plug this back in here, I've got the square root of negative 9 minus 2 times a negative 6, okay, equals the square root of 2 times negative 6 plus 15. Okay, so that's going to be negative 9. That's going to be a positive 12. Negative 9 plus 12 is going to be 3. So I've got the square root of 3 equals, that's going to be negative 12. Negative 12 plus 15 equals the square root of 3. Square root of 3 equals square root of 3. That checks out. So x equals negative 6 is the correct answer. Okay, number 3. All right, do I have one of my radicals isolated? Yes, I do. So let's go ahead and square both sides. Alright, when I square that, they cancel out, so I'm left with 2x minus 3. Alright, now when I square x minus 3, you can do one of two options. You could go ahead and FOIL out x minus 3 times x minus 3. First, outside, inside, last, that's perfectly fine. Or if you remember the shortcut, like we talked about in class, if you have a minus b squared or a plus b squared, you're going to square the first term. You're going to multiply the two guys inside together. A times negative b is negative ab. Then you're going to double that, so that's minus 2ab. And then you're going to square the back term. Negative b times negative b is plus b squared. Okay, so the shortcut for a perfect square trinomial, a plus b squared or a minus b squared, is you square the first term, you multiply the two inside and double it, and then square the back term. If this had been a plus b squared, then it's the same exact thing. It's just that the middle term is positive. A squared plus 2ab plus b squared. And that's all review from last year. All right, so what do we do with that guy? That's my a and that's my b. I square the first term. I multiply a times b. Negative 3 times x is negative 3x. I double that, so that's minus 6x. And then I square the back term. Negative 3 times negative 3 is a positive 9. Get my camera to refocus here. All right. And now I've got a quadratic I need to solve, set everything equal to 0. So if I subtract 2 from both sides, that's going to be a negative 8x. If I add 3 to both sides, that's going to be plus 12. That's going to be equal to 0. All right, so what are the factors? Can I factor this quadratic? Factors of 12 that add to negative 8. That's going to be a negative 6 and a negative 2. So x minus 6, x minus 2. Flip the two signs, and I get 6 and 2. All right, so let's go back and check to see if one or both or none of these are extraneous. Okay, so if I take the 2 and plug in the 2, I'm going to have the square root of 2 times 2 minus 3, okay, equals 2 minus 3, and let's see if that checks out. So I have the square root of 4 minus 3, that's the square root of 1, equals 2 minus 3, which is negative 1. Square root of 1 is 1. 1 does not equal negative 1, okay? So 2 is extraneous. Okay, what about the 6? If I plug in the 6, I'll have 2 times 6, which is 12. 12 minus 3, which is 9. The square root of 9 is 3. All right, if I plug in a 6 here, 6 minus 3 is 3. 3 equals 3. That checks out. All right, so 6 is the correct answer there. Okay, little hint here if you're watching the video. One of the hardest types of problems that we did, and this was one of the problems on our quiz, if I have something like this, if I say I have the square root of 2x plus 3 equals 4 minus the square root of x plus 7, you may or may not have a question like that on the test tomorrow. Okay, just saying. So you might want to go back and look at your notes, look at that problem from the quiz, and remember what to do, because when I square both sides here, you've got to remember what to do when I square all this stuff. Okay, you've got to square that first term. You've got to multiply these together. 4 times negative root x plus 7 is just negative 4 root x plus 7. I'd have to double that. So that'd be negative 8 square root of x plus 7. And then square the back term, all that cancels. So I'd be left with plus x plus 7. And then I'd go on to solve from there. Okay, so hint, 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 you might have a problem like that tomorrow. Okay. All right, so let's go on to number 4, word problem. Mr. Maniz, what this is? Word problem. We haven't done any word problems. I know. You guys are gifted accelerated. I expect you guys to be able to take what you've learned and apply it to a word problem. It's really not that hard. You just got to break it down slowly, reading comprehension. Make sure you understand what the problem is asking. Josh has been contracted to water lawns for the summer using circular sprayers. The radius of sprayed water, R, in meters is modeled by this formula. R equals the square root of 0.49a, where a is the area of grass watered in square meters. Determine the area covered for a circle with a radius of 4 meters to the nearest tenth of a meter. Okay, let's read this one more time. Okay, contracted water lawns. I'm trying to model what your brain needs to go through. Okay, so contracted water lawns using circular sprayers. The radius R. Okay, radius R is modeled by this formula. Okay, got it. A is the area of the grass watered. Okay, so the area. So here's the area of the grass that's being watered, and here's my radius. Okay, determine the area covered for a circle with a radius of 4 meters. Okay, so I'm trying to find the area. So I'm trying to find A. Get my camera to refocus. Come on. Come on, you can do it. There we go. Okay, so I'm trying to solve for determine the area. You got to read the questions. What is the word problem asking for? Determine the area. Determine A. with a radius of 4. Okay, so they give me the radius. Okay, so let's plug in what we know. Always draw a picture, start plugging in what you know if you don't know how to get started. Okay, they've given me the radius. The radius is 4. So 4 equals the square root of 0.49 times a. Okay, just treat this like a normal problem. Just treat this like an x. You know, how would I get x by itself? Well, let's follow our rules. Do I have one of my radicals isolated? Yes, I do. So if that's the case, I can square both sides. All right, 4 squared is 16. When I square the square root of something, they just cancel. So 16 equals 0.49a. Imagine if that were an x. How would you get x by itself? You divide both sides by the coefficient in front of it. All right, and so a is going to be equal to 16 divided by 0.49, which comes out to be 32.7 meters. Now this says round. Normally we don't care what we round to, but the word problem says round to the nearest tenth. Okay, so make sure that you're following the instructions tomorrow if it says round to the nearest whole number, nearest tenth, or whatever. So let's stop for a minute and ask ourselves, does this make sense? Does this make sense? I've got a radius of 4 meters. Do you buy the fact that we're covering 33, and this is actually area, right? So this actually should be meters squared, okay? Do you buy the fact that this radius is 4 meters, back to our drawing, and we're covering 33 square meters of grass? Do you buy that? Yeah, I buy that. That sounds reasonable to me. Okay, so always ask yourself, does my answer make sense? Okay. All right, let's keep going. Number 5. Write each expression in radical form or as a rational exponent. So here we're just converting back and forth. You got to remember power over index. Power over index. Okay. So power over index. So the 7 is my power, and the 6 is my index. Power over index. Okay, when I write this in radical form, I'm going to have the square root symbol. Okay, now notice that this is something that a lot of students missed on the quiz. You've got to pay attention to whether or not you have parentheses or not. All of this inside the parentheses is being raised to the negative 7/6 power. So the whole 10x, all of that is in parentheses. Okay, the power is the 7. Okay, so 10x to the 7, and the index is the 6. Okay, so the 6 goes in the little crevice right there, but it's being raised to the negative 7/6 power, so that means that we would have to flip it, so that means all of this is under 1. Okay, you could also write this as 1 over parentheses the 6th root of 10x and just put parentheses on the outside like that. My personal preference is just to put the parentheses on the inside, just because I like to see it written like this, like the parentheses and then immediately the exponent. Parentheses and then immediately the exponent. Although, I forgot to put the 7. Although if you put the parentheses on the outside of the whole little square root symbol and then put the power on the outside, that's perfectly fine too. Okay, and we can check this. Okay, I got a little bit surprised on the quiz with how few students actually took the time to check this. Okay, so let's check this real quick. I want to make sure my x is not 0. Okay, so let's type in parentheses 10x parentheses raised to the negative 7/6. Oops. Parentheses 10x parentheses raised to the negative 7/6. Okay, get some number. We are saying that's the same thing as 1 divided by, now if I want to do the 6th root, okay, so I'm going to press 6, and then I'm going to press math, and if you go down here and look at option number 5, there's where you can take the nth root, or the xth root, okay, so I want the 6th root, so I'm going to press 5, and now notice that my calculator throws a little index in there, so I'm taking the 6th root of parentheses 10x parentheses raised to the what? Raised to the power, raised to the 7, okay, and you can see they match. Okay, now if you guys up here, if you didn't put that in parentheses, if you just put 10x raised to the negative 7 divided by 6, you'll notice that, wait a minute, they didn't match. So that says, oh yeah, I forgot to put the parentheses in there. Okay, so it doesn't take very long to check these things. All right, 6, we're going backwards. Okay, so the 7n, all of that is being raised to the power. The 2 is my power, and the 3 is my index. Okay, so all of that is in parentheses, so the 7n, the whole 7n, is being raised to the power 2 over index. However, all of this is under 1, correct? So if we flip that, if this is on the bottom, that means our exponent is to the negative 2/3. Okay, let's check this real quick. I'll use an n this time. 1 divided by, now here I'm just doing the cube root, so I'll do math option 4, the cube root of parentheses 7 alpha n parentheses raised to the second power. Okay, we are saying that that is equivalent to parentheses 7 alpha n parentheses raised to the negative 2 divided by 3. And they match. Again, if you did not put parentheses around that, if you just put 7 alpha n raised to the negative 2/3, they won't match. Okay. All right, easy peasy. All right, let's move on to the tougher stuff. So our rational exponents. Remember, you can only have positive exponents in your final answer. It shouldn't have any negative exponents. Okay, so just like we talked about in class, kind of the way that I approach these problems is I look to see, is there anything, do I have parentheses? I look for, does anything raised to the 0? I look for coefficients that I can pull out. I look to see if there's anything that can immediately cancel on the bottom of the top. I don't see any parentheses, nothing raised to the 0. We don't even have a fraction, so my brain immediately sees that guy right there. All of this stuff is being multiplied all together. Something times something times something times something times something. Okay, it's all multiplication, so I'm going to pull this guy out front. Okay, I know that my final answer is going to have a 2 out in front of all this stuff. Okay, so now it's time to match up the x's. I've got an x squared times an x to the negative 5/3. Now again, if you guys want to just do this on your calculator, that's no problem. Okay, I'm adding 2 minus 5/3. So you can just type that in. 2 minus 5 divided by 3. Get some number, press math, fraction, press enter twice. 1, 2. And that converts that to 1/3. Okay, so that's 2x to the 1/3. For the y's, I've got a y to the 1 and a y to the 1/2. So 1 plus 1/2, math, fraction, that is 3/2. Okay, so 2x to the 1/3, y to the 3/2. Okay. Now, if you want to get common denominator for all of these, which is fine, I've got x squared, and then I've got x to the negative 5/3. What's the common denominator? Common denominator is 3. So that guy needs a 3 over 3. So this will be x to the 6/3 times x to the negative 5/3. Okay, and then I just add. That's going to be x to the 6 minus 5. That's going to be x to the 1/3. Well, that's what we got up here. For the y's, I had y to the 1, and I had a y to the 1/2. If I add those, I need a common denominator. Common denominator is 2, so that guy needs a 2 over 2. So that's y to the 2/2 times y to the 1/2. Add those, that's y to the 3/2, which is the same thing we got up here. Okay, can we check this all day long? So once again, make sure that your x's and y's are not 0. So as long as it's some number, you're okay. Okay, so let's type in alpha y, x squared, times 2x raised to the negative 5 divided by 3. Bring my, oh, y'all can't see that. Bring my cursor back down. Alpha y raised to the 1/2. Okay, ooh. Okay, I'm actually glad this happened. I didn't do this on purpose, but I'm glad this happened. The reason why this happened is because my y was a negative value, and you can't raise a negative value. You cannot take the square root of a negative. So once again, I'm not sure why these numbers in your calculators get changed. It's something you guys are doing in your science classes, I think, with scientific notation, because I had you guys assign a number to every letter, but those letters, especially the x's and y's, are subject to change. So anyway, I'm just going to go back and restore my y. So the z was 28 and the y was 27. So I'm going to go 27 store alpha y, enter. Okay, and then my x is supposed to be 26. So 26 store x. Okay, now it'll work. All right, so let's plug in our original problem. Alpha y x squared times 2x raised to the negative 5 divided by 3. Bring my cursor down. Alpha y raised to the 1 divided by 2. and I get some number. We think that's equivalent to 2x raised to the 1/3. Bring my cursor down. Alpha y raised to the 3 divided by 2. Y raised to the 3 divided by 2. And they match. All right, let's move on to the next one. Okay, I don't see anything to the 0. I don't see any coefficients. I see parentheses. So let's go ahead and use our power rule here. So that's going to be x to the -1, y to the -2/3. With the power rule, you multiply these guys together. I multiply -2 over 1 times 2 over 3, and that is -4 over 3. Okay, so that's going to give me times y to the -4/3. Okay, so I can't do anything with the x, that's just by itself, so I've got x to the -1. Here I can add these. -2/3 minus 4/3, they have a common denominator. -2 minus 4 is -6, so that's y to the -6/3. Okay, and always simplify your fractions here. So that's x to the -1, y to the -2. Alright, and then both of these are negatives, so I got to put both of these guys on the bottom. So it's 1 over x to the +1, y to the +2. 1 over xy squared. Okay. For sake of time for this video, I'm not going to go back over. You guys can practice working on checking this and plugging this into your calculator. Okay, number 9. All I see are x's. Nothing raised to the 0 power, no coefficients. So there's a couple of things you could do here. You could go ahead and use the power rule and multiply those. You could go ahead and take this guy and put it up top. That order actually really doesn't matter. I'll go ahead and multiply these first. 2 times 2/3 gives me x to the 4/3. Alright, and then I've still got the x to the -3/2. Now here you could go ahead and do the quotient rule if you wanted to. You could do -3/2 minus a 1/2, but you're subtracting a negative. So typically what I like to do is something like this. When I've got something on the bottom that's got a negative exponent, typically I like to just throw it up top and change the sign. So if I move this whole thing to the top, that becomes x to the +1/2. And now notice I don't have a denominator anymore. So now I'm just using the product rule where I just add all these guys together. Now again, if you just want to use your calculator, add them all together, that's fine. 4 divided by 3 minus 3 divided by 2 plus 1 divided by 2. Math. Fraction. Okay, that comes out to be x to the 1/3. Okay. If I want a common denominator, the common denominator is 6. So that guy needs a 2. So that's x to the 8/6. That guy needs a 3. So that's x to the -9/3. Or excuse me, -9/6. 6. And then that guy needs a 3. So that's x to the 3/6. So I've got 8/6, -9/6, and 3/6. If I add all those together, 8 minus 9 is negative. Did I do that right? Yeah, okay, sorry. I just had a little glitch there, I'm sorry. 8 minus 9 is -1. -1 plus 3 is 2, so that's x to the 2/6. I saw the 2 and I got confused there because I knew it was 1/3, but 2/6 obviously reduces to 1/3. Okay, so x to the 1/3 is correct. Okay, I'll show you how to check this one real quick just because there's some funky stuff going on here. But here I'm going to need 2 sets of parentheses because I've got that set of parentheses, but then I want this whole thing divided by x to the -1/2. So I'm going to use 2 sets of parentheses. The inside is going to be x squared. That is going to be raised to the 2 divided by 3. Bring my cursor down. And then I also have times x raised to the -3 divided by 2. Okay, and then all of that whole numerator is being divided by x raised to the -1/2. Okay, and we get that. We are saying that that's equivalent to x raised to the 1/3. And they match all day long. Don't turn your test in that box until you check these. All right, number 10. Okay, number 10 is a little bit more complicated. I don't see any parentheses. I don't see anything raised to the 0. Do I see anything that cancels? Yeah. I've got coefficients on the top. I've got a 2 on top. All of this is a multiplication. There are no pluses or minuses. So when there's no pluses or minuses in a fraction, you can cancel stuff. So the 2 and the 2 cancel, and I'm just left with this 4. Or you could have done 2 times 4 is 8. 8 divided by 2 is still 4. Okay, so I'm looking at that guy, and I'm thinking to myself, okay, there's going to be a 4 out in front on top. If there ends up being a fraction, it's going to be in the numerator. Okay, so I've got a 4 out front. Now I don't have to worry about these coefficients anymore. Now I'm just kind of focused on the variables. Okay, again, I see a variable in the denominator that's got a negative fraction. I don't like that, or excuse me, negative exponent. So I'm going to take this guy and throw him up front. All right, so I've got 4x to the negative 1/2. And then I have y, and then x squared, and I have, okay, let me back up here. Some of you guys may look at this and say, oh, I've got a 7/4 on top and a 7/4 on the bottom. Those don't cancel because this one's raised to a positive 7/4 and that one's raised to a negative 7/4. So those do not cancel. Okay, so up here on top, I've got the original x to the 7/4, and then y to the negative 3, and then I'm throwing this guy on top. So now I have another x to the 7/4 on top. Okay. All right. So let's go ahead and start simplifying this. So I've got the 4 out front. All right, for the x's, I've got negative 1/2 plus 2 minus 3. Okay, so once again, I can just do that on my calculator. Again, for sake of time for this video, I'm not going to get a common denominator. I'm going to let you guys practice that. I'm just going to punch this into my calculator. Negative 1 divided by 2, and then I've got the x squared, so that's plus 2, and then I've got the, okay, so I've got x to the 1/2, I've got an x squared, I've got a 7/4, so plus 7/4, and then I have another 7/4, so plus another 7/4. Okay, I get 5. Okay, well that was easy. So that's just 4x to the 5th. Okay, and then for the y's, I have a y to the 1 and a y to negative 3. 1 minus 3 is negative 2, so I have y to the negative 2. That guy goes on the bottom, so that equals 4x to the 5th, and only the y squared goes on the bottom. Okay, and once again, you guys could check this. All right, so home stretch here. So let's go ahead and look at these last two where we're graphing our radical function here. And so we want to state the transformations, the point of origin, and the domain and the range. In this first one here, I've got a square root, so I'm thinking my graph, looks something like that. All right, so I'm just going to write T for transformations. Let me zoom out here just a little bit. This one. Okay, T for transformations. Again, there are 4 different types of transformations you can have with these radical functions. Number 1, do I have an x-axis reflection? Do I have a negative in front of the coefficient? Yes, I do. Okay, so I have, don't say reflection, x-axis reflection. Okay. Next thing I look to see is, do I have a coefficient in front of the square root symbol? Yes, I do. That's going to be my stretch or shrink, since the absolute value of negative 2 is 2. Remember, the negative has no effect on the stretch or the shrink. The negative only means you're flipping across the x-axis. Okay, so I have a stretch of 2, or a stretch by 2. Okay, and then my h value inside the radical here, that's my horizontal shift, but remember it's x minus h. So we have y equals a times x minus h, and then plus k. The k is on the outside. It's minus h, so you got to flip this. This is the opposite of what you think it would be. Just like this was vertex form for quadratics last year in geometry, you got to flip it. So you might think, oh, I'm going to right 1, but it's the opposite. So this is actually going to be left 1. If you can't remember that, if you get confused on this, plot the graph and look to see, is my
Front office.
I didn't press the button.
All right, sorry.
Okay, so sorry about that. Look to see, is my graph shifted 1 to the right, or is it shifted 1 to the left? And you won't have to, if you forget about that, you won't have to question it. You'll know exactly what it does. And then the last one is my vertical shift, that my k value, so that's going to be up 4. Okay, and then what is my poo? Yes, we call it poo. That's the point of origin. The point of origin, the poo, is just your h comma k. Okay, so for the poo, I flip that sign. That's going to be a -1, and I leave that sign alone. So -1 comma 4. All right, so let's go ahead and plot that. -1 comma 4 is about right there. Now remember, our normal radical is going to do something like that, but we have an x-axis reflection, so that means it's going to do that, and then we have a stretch of 2. So not only is it going to do that, it's going to be stretch. Okay, it's going to be wider, broader. Okay. Now, if you want to go grab a couple of points, you're welcome to do that. So if I plug this into, you need to graph this anyway. So -2 second square root of x plus 1. Press the over button. You got to press this to get outside the radical. Okay, you cannot leave this as plus 4. Okay, do y'all see that right there on the video? That plus 4 is still inside the radical. Don't make that mistake. So let's get outside the radical. Now notice the cursor is outside of the radical bar stopping, and then plus 4. Okay. All right, let's graph that, see what it looks like. Now you can give me a general sketch from this, or you can go to second table, and let's go grab some points. Okay, 3, 0 is a point, so I can grab that one. And really and truly, that's enough. That kind of tells us exactly how this graph is going. So something like that. Okay, next one over here. We have a cube root, so you should be thinking, okay, the snake's going up the tree. All right, so our transformations. Do I have a reflection? Yes, I do. So I have an x-axis reflection. Do I have a stretch or shrink? Yes, I do. That's less than 1. 0.3, 2/5, some kind of fraction will be a shrink, so that's a shrink by 1/2. Okay, so well, let's just finish the transformations. Okay, so that's going to be left 3 and again up 4. Okay, so I've got an x-axis reflection, shrink by 1/2, left 3, up 4. Now our normal snake goes up the tree, but it's an x-axis reflection, so now the snake's going to go down the tree. And then it's also a shrink of 1/2. So that means it's going to be really, really skinny. Really short, narrow, and skinny. Okay. So our poo, point of origin, flip that sign, leave that one alone, -3, 4. And then let's go ahead and graph this. I forgot to do domain and range. I need to get back to do those. So -1/2 second square root of x plus 3. Let's get outside the radical, plus 4. Let's graph this. Okay, so the poo is -3, 4, which is about right there. Okay, and this again, this is going to be pretty skinny. All right. Oh, actually, you know what? I didn't do the cube root. Whoops. Okay, -1 divided by 2, math cube root, excuse me, cube root of x plus 3, get outside the radical, plus 4. All right, I knew that was wrong because it didn't have the snake. Okay, so here's that backwards skinny snake here. So our graph's going to look something like this. Okay, there's the graph. All right, domain and range. The domain and range for all cube roots is always -infinity to infinity. And let's go back and do the domain and range on number 11 here. Domain, okay, where do I have x values? The domain and range, guys, is always based around your poo, the h and the k. Okay, so that's x value and that's y value. Okay, so I'm only for the range, for the domain, I'm only looking at the x values. I don't have any x values over here. I don't have any x values until I hit this guy right here. So my domain is going to go from that guy, -1, and I will continue to have x values forever, -1 to infinity. And then the range is going to be based on the k value of my poo. So again, you're sweeping from bottom to top on the range. I will have y values from -infinity all the way until I hit this y of 4. So my range is -infinity up to that y coordinate of the poo, which is -4. I will always have brackets on the x and y coordinates of the poo for domain and range. You will always be touching that point because you're physically touching the point of origin. Okay, so hope you guys, let me focus this real quick so I can see that. Okay, so hope you guys enjoyed that video. Good luck on the test, and we will see you on the next one.